Once again, let's have a look at hypothesis testing of the first type that we discussed. Hypothesis testing about individual regression coefficients. Like I said, the most commonly tested null hypothesis would be something like this, where I'm saying my null hypothesis H naught is that beta 2 hat, beta 2 is equal to 0. That is, the null hypothesis is that the population parameter beta 2 is equal to 0 versus the alternate hypothesis that beta 2 is not equal to 0. So first understand what the null hypothesis means. If beta 2 is equal to 0, that would mean that the variable attached to beta 2, that is per capita GNP, has zero impact on child mortality. So our null hypothesis is stating that per capita GNP has zero or no influence on child mortality. And alternate hypothesis says that beta 2 is not equal to 0. That is, the per capita GNP has some sort of influence, either positive or negative, but in a statistically significant manner. Okay, so if this is the null and alternate hypothesis, my t statistics for this statistic for testing this hypothesis will be beta 2 hat minus the hypothesized null value, which is 0, divided by standard error of beta 2 hat, right? And this would because my null, the hypothesized value is 0, this is basically beta 2 hat divided by standard error of beta 2 hat, which is 0.0056. I got that from the first line, divided by standard error of beta 2 is also calculated and given in the output, 0019. If you actually use your calculator, you will get this as, it is minus 0.0056. So if you do this division, you will actually get the value as minus 2.8187. This is nothing but the t value that has been quoted in the output. So remember that this entire row of t values corresponds to null hypothesis that the population partial regression coefficient is equal to 0. Okay, so if you remember your rule of thumb, what did it say? Your rule of thumb, 2 minus t rule of thumb, said that if the t value calculated in absolute terms exceeds the value of 2, then at 5% level of significance, you may reject the null hypothesis. That is, you reject the null hypothesis that beta 2 equals to 0, which means beta 2 is, you're accepting the alternate hypothesis that beta 2 is not equal to 0. That is, the variable per capita GNP has some sort of influence, statistically significant influence on child mortality. Right? Like I said, if you have chosen or determined your alpha to be 5% level of significance, you can see that the p-value 0.0065 is much less than 0.05. So also you are saying that the beta 2 parameter is statistically significant, which means per capita GNP has a significant influence on child mortality. Now you can also test this hypothesis by building confidence interval estimates for population beta 2. So that would mean so based on, if you remember, your confidence interval, 95% confidence interval for the population parameter beta 2 can be predicted using this formula. So it's beta 2 hat minus t alpha by 2 times standard error of beta 2 hat less than equal to beta 2 hat plus t alpha by 2 times standard error of beta 2 hat. Now remember, if alpha is 5% or 0.05, so you are looking at t 0.025 from the t tables, and you will be looking up under, ideally under 64 degrees of freedom, because no, not under 64 degrees of freedom, under n minus 3. So 64 minus 3, that is 61 degrees of freedom from the t tables. But if you look up the t table in the last few pages of your Damodar Gujarati book, you will see that we only have values till degrees of freedom equals to 60. Since this regression output table was produced by a computer program, that was not a matter. Okay, so as an adjustment, we will take t alpha by 2 value for degrees of freedom equal to 60, right? Of course, for the time being, we can also use the values which has been given in the output. So beta 2 hat is minus 0.0056 minus the t alpha by 2 value approximately 2, and standard error of beta 2 hat is given as 0.0019, which is less than equal to beta 2, which is less than equal to beta 2 hat minus 0.0056 plus 2 times 0.0019, right? So approximately this will work out to be minus 0.0096 less than equal to beta 2 less than equal to minus 0.0016. This is the 95% confidence interval for the true beta 2 coefficient. What does that mean? It means that if, similar to this, I take a total 100 samples, each of size 64, and for each sample I calculate confidence intervals of this sort, then in 95 out of these 100, I expect to successfully contain the true population parameter beta 2, right? in the case of this specific sample, remember my null hypothesis was beta 2 equal to 0 versus alternate hypothesis beta 2 not equal to 0. So in this case, as you can see that the null hypothesized value 0 is not in this interval that we have estimated. So we may reject the null hypothesis and accept the alternate hypothesis that per capita GNP has a significant impact on child mortality.